Welcome to my YouTube channel. In this video, we are going to learn about Gibbs phase rule. So, without wasting more time, let's start the video. So, the content that we are going to learn is first Gibbs phase rule general formula. There is one rule, or we can say there is one formula that we will describe in detail. After that, we solve some example. In this way, we understand Gibbs phase rule properly. So, and after that, third is Gibbs phase rule for constant pressure. There is one different formula for constant pressure that we also learn in details. After that, we solve some example related it. So in this way, we understand this Gibbs phase rule properly. So let's start. So first we describe the Gibbs phase rule formula, that is P plus F is equal to C plus 2, where P is the number of phase and F is the degree of freedom, or sometimes it's called as a variable, and C is the number of components. So by using this formula, we are going to find out degree of freedom, that is denoted by F. This formula is very simple and straightforward. So directly let's solve some examples. Our first example is ice. Consider there is one ice cube. So tell me how many phases the ice cube have. Obviously ice cube is in solid form, so number of phases is 1, that is P is equal to 1. And tell me now how many component that ice cube have. Ice cube is made by the water, so that is H2O. So obviously number of component is also 1. So we need to find the F, that is degree of freedom. So our formula for finding degree of freedom is P plus F is equal to C plus 2. So let's put the value of P and C by just simplify this for equation, and we get the value of F, that is 2. This is our degree of freedom for ice cube. Second example is water plus ice. So as shown in figure, consider we have one glass of water in which we drop some ice cube. So now tell me the how many phases we have. Obviously liquid and solid, so we have two phases. So P is equal to 2. Tell me number of components that we have. Obviously water and ice cube are known as a H2O, so number of component is 1, that is C is equal to 1. So let in this example also we find the F. So F is nothing but degree of freedom. Our formula for finding degree of freedom is P plus F is equal to C plus 2. Just put the value of P and C, just simplify this, and we got the value of F, that is our degree of freedom for water plus ice. So next example is, consider we have steam plus water plus ice. So now tell me how many phases that we have. Obviously we have 3 phases, that is steam plus water plus ice. So P is equal to 3. Now tell me how many components that we have. Steam, water and ice are made by the H2O. That means, so we have one component, that is C is equal to 1. In this example, we also find the F, that is degree of freedom. Our formula for finding degree of freedom is P plus F is equal to C plus 2. Just put the value of P and C and simplify this equation. We get the value of F, that is 0. So our degree of freedom is 0 for steam plus water plus ice. When degree of freedom is 0, it is also called as a triple point, where 3 phases are coexist. Now let's see how to find out degree of freedom for constant temperature. Also sometimes it's known as the degree of freedom for material. There is slight change in formula, that is P plus F is equal to C plus 1. Here we take constant as a 1. So as we learned previously, P is equal to number of phases, F is equal to degree of freedom, and C is equal to number of components. Now let's move to the examples. First example, in this example we have to find the degree of freedom for AB region. Before moving further, first we need to understand this diagram. This is cooling diagram of any X mechanical material. At AB region, our material is in molten phase. We can also say it as our material in liquid phase. If we further cool down our material, now the state of our material is liquid plus solid. Again we further cool down our material, so the state will be completely solid. This is our cooling diagram of our material. Now let's find out the degree of freedom for AB region. At AB region, how many phases do we have? There is only molten metal is present, so number of phases is 1. Now, how many components do we have? We have two components. At point A there is molten metal, and at point B our metal is in our molten metal is start solidifying. So that's why at AB region we have two components. As we know, our formula for finding degree of freedom is P plus F is equal to C plus 1. Just put the value of P and C and simplify the equation. We get the value of F, that is F is equal to 2. So our degree of freedom for AB region is 2. Now next let's find out the degree of freedom for at BC region. How many phases do we have in BC region? Obviously we have two phases. There is liquid plus solid is present. Now tell me how many components do we have? At BC region we have liquid plus solid. As we know, molten metal and solid material chemical composition and material structure is totally different. So that's why at BC region we have two components. Here also we need to find the degree of freedom. Our formula for finding degree of freedom is P plus F is equal to C plus 1. Just put the value of P and C and simplify the equation. We get the value of F, that is 1. So degree of freedom for BC region is equal to 1. So let's move to the next example. Now now let's find out the degree of freedom for CD region. Tell me how many components do we have at a CD region? Obviously there is only solid material is present, so number of phases is 1, that is P is equal to 1. Now tell me how many components that we have in CD region. Obviously we have two components. At C and D there is slight change in microstructure of material, that's why we have two components. In this example we also need to find the degree of freedom, that is F. Our formula for finding degree of freedom is P plus F is equal to C plus 1. Just put the value of P and C and just simplify the equation. We get the value of F, that is 2. So our degree of freedom for DC region is 2. So that's it for today. I hope you understand. If you like this video, please subscribe to my channel, and thank you. See you in the next video.